Autophagy acts as an internal metabolic compass, one that not only cleans and renews, but also redirects energy resources when external fuel is scarce. During low-carb states, especially when glycogen stores are running low, the body doesn't simply stall, it adapts. And autophagy is central to this adaptation. Rather than relying solely on dietary carbohydrates to fuel metabolism, the body taps into a deeper, more versatile energy strategy, recycling its own cellular components. In this way, autophagy becomes a bridge between carbohydrate scarcity and metabolic continuity, enabling survival, focus, and even cellular renewal in the absence of sugar. At first glance, glycogen depletion might seem like a metabolic emergency. The body's stores of quick-release energy, housed mainly in the liver and muscles, are limited. Once these stores are used up, particularly after 12 to 24 hours of fasting or during prolonged low-carb intake, blood glucose levels begin to drop, insulin decreases, and glucagon rises. This shift flips the cellular energy sensors. YMPK is activated, mTOR is suppressed, and autophagy is initiated, not merely to clean house, but to repurpose what the body already contains. It's a graceful internal pivot, where old proteins, damaged mitochondria, and redundant cellular machinery are broken down and converted into usable substrates like amino acids, fatty acids, and even glucose precursors. This process, referred to as autophagic nutrient recycling, is crucial for sustaining energy homeostasis without relying on food. Amino acids liberated from autophagic protein degradation can be used for gluconeogenesis, allowing the liver to generate small amounts of glucose for critical tissues like the brain and red blood cells. At the same time, the breakdown of intracellular lipids and dysfunctional organelles supports the shift toward fat-based energy production, including the generation of ketones. These ketones not only supply energy to the brain and muscles, but also enhance autophagy in a positive feedback loop, deepening the body's capacity for self-repair. The liver plays a key role in orchestrating this metabolic ballet. When hepatic glycogen is exhausted, autophagy ramps up, breaking down intracellular structures to maintain ADP levels and meet the demands of the entire organism. Skeletal muscle, too, contributes by increasing autophagic turnover to supply amino acids and clear out older components under energy stress. This is not a signal of breakdown but of prioritization, the body intelligently choosing what to preserve and what to recycle. In effect, autophagy becomes the mechanism through which energy scarcity reveals and resolves inefficiencies hidden in the system. What's especially fascinating is that this process isn't purely reactive, it's also regenerative. While the body is burning down less essential parts for survival, it's simultaneously triggering cellular pathways that lead to improved mitochondrial function, reduced oxidative stress, and even stem cell activation in some tissues. This is why low-carb or fasted states, when entered cyclically and safely, often lead to improved metabolic flexibility, sharper cognition, and better insulin sensitivity. Autophagy does not simply delay collapse, it creates renewal from within. And the implications go further. In athletes practicing glycogen-depleting exercise followed by carb restriction, autophagy enhances muscular adaptation, accelerating mitochondrial biogenesis, and improving endurance. In the brain, low glucose conditions combined with autophagy stimulate synaptic pruning, memory consolidation, and even neurogenesis. In the immune system, autophagy helps regulate inflammation and remove dysfunctional white blood cells, many of which are sensitive to nutrient signals. This dynamic regulation of glycogen, energy, and autophagy helps explain why humans can go extended periods without food and still perform complex tasks, even thrive. It's a survival mechanism encoded in our biology, honed through millennia of feast and famine cycles. In the modern world, where carbohydrate access is near constant, this elegant dance between glycogen use and autophagy is rarely allowed to unfold. But when given the opportunity, whether through low-carb diets, time-restricted eating, or exercise, the body remembers how to reroute, recycle, and regenerate. In short, autophagy is not just a cleanup process. It's a strategic energy manager during carbohydrate scarcity. It extends the life of internal resources, sustains metabolic balance, and simultaneously rewires the body for greater resilience. Far from being a stress response in the negative sense, it is a return to metabolic wisdom, a state where the absence of one fuel becomes the ignition of a deeper, cleaner, and more purposeful energy system.